Hello friends, I am Dr. Sarika Panwar. We will continue our discussion on machine learning. In last lecture, we have discussed introduction of machine learning, what is machine learning, and various applications of machine learning which we come across in our daily life. Now, today we will discuss the types of learning. As far as machine learning is concerned, the learning types are categorized in either supervised learning, unsupervised learning, or reinforcement learning. In this diagram, you can observe the difference. In supervised learning, the label data is used. Using the label data, direct feedback is given from the output to the input, and various parameters for learning are updated, and prediction about the future can be done. In unsupervised learning, unlabeled data is used, so there is no feedback from output to input. Unsupervised learning is used to find the hidden structure in the data, or we can say to form the clusters based on the characteristics of the data points. Third category is reinforcement learning, in which there is a reward system. Decisions are taken based on the reward, and from that the system can. Now we will discuss the supervised learning in detail. With this example, now we can understand the supervised learning. Here we can observe there is a label data. What is the meaning of label data? With this data, the labels are also associated. These are the input data points, and these are the labeled values of those data points. Now, if this triangle, this hexagon is given, this label data is given for model training, and based on this training, the system will learn and it will output a model. Now that model can be used to test the unlabeled future data which the system has not seen while training. Now for this test data, the system should be able to give the decision that this particular figure belongs to square or triangle. That is about the supervised learning. So in supervised learning, a set of input features x1, x2, these are the input features. A set of input features with its corresponding label target feature y is used for training of a system. Now in this example, if we try to understand what do you mean by features, then we can see that these figures differ in the number of sides. So number of sides here in triangle are 3, in hexagon number of sides are 6, and in square number of sides are 4. So the number of sides can be the input feature, and hexagon, this is the label. So if this data, this whole data we give, this label data if we give for training, then the system will learn from its feature that if a particular figure has 6 sides, it belongs to hexagon. If a particular figure has 3 sides, it belongs to triangle. So such training it will take from that label data, and it will come up with a proper model. Now that model can be used for prediction for the data points which it has not seen while training. So this we can call a test data or unseen data. When this figure, this unlabeled data is given as an input to the system, it should be able to predict whether it belongs to square or triangle. So that is supervised learning. can see that a set of training examples where the values for the input and target features are given for each example, and a new example where only the values for the input features are given should be able to predict the values for the target feature for the new example. In supervised learning, there are two types: regression and classification. This is the example of a data points for classification problem, and this is for the regression problem. Now, what is the difference between classification and regression? In classification, the output y is discrete in nature, whereas in the regression, the y is continuous in nature. We will try to understand the classification process where the outputs are discrete in nature. Consider that if we have to model a classification system for differentiating the low risk customer from the high risk customer, and the input parameters for differentiation are suppose income and saving. If a particular customer has a income greater than theta 1 and savings greater than theta 2, then that customer will be categorized as low risk customer, otherwise high risk customer. So bank will rethink about their decision whether to give the loan to high risk customer or not. So here there are only two output classes. The particular data points will either fall in low risk category or high risk category. So that's why such type of problems are called as classification problem. Now next is regression. For understanding the regression problem, we will consider this example where we have to predict the car price from the mileage. The mileage as an input is given to us, and we have to predict the car price. If the mileage is having particular value, we have to predict the price of a car. So a car price can take any value, like it can be 1 lakh, 2 lakh, 1.5 lakh, 3.5 lakh. So there is no certain category in which the price will fall, like we had in the classification example. There was only two categories where the data point may fall, but in this case there is no discrete category. It can take any continuous value, like 1 lakh, 2 lakh, 3 lakh, 3.5 lakh, 3.1 lakh. So these values are continuous in nature, and such problems are regression problems. Now next category is unsupervised learning. Unsupervised learning is generally used to form the clusters. In unsupervised learning, we use unlabeled data, means class labels of the data are unknown to us. And what will be our task? That will be to establish the existence of classes or clusters in data. We will consider one example for this. Consider that these input images are there, the image of Mozambique, the image of apple, apricot, like that. So we, at the time of training, we don't know that this particular image belongs to apple category, this particular image belongs to Mozambique category, this belongs to apricot category. That we don't know. But the characteristics of these images can be used for learning, and that is what done in unsupervised learning. Similar characteristics images are grouped together. So all the images having a particular shape, having a red color will be grouped together. Here all the images having green color will be grouped together. All the images having orange color and having particular shape will be grouped together. Based on its characteristics, the clusters or groups will be formed. That is unsupervised learning. Here we can observe that this is original unclustered data. During the training process, what is done? The data points having the similar characteristics will be grouped together. So here, based on the characteristics of data points, 3 groups are formed, 3 clusters are formed. This is how clustering is done in unsupervised learning. Third category is reinforcement learning. Reinforcement learning is totally a different paradigm. Here in reinforcement learning, there is one agent and one environment. Agent takes some action for the environment, and based on that action, some parameters in the environment will change, and based on that, the rewards will be given to the agent. It is like our closed loop system where we take the feedback, and based on the feedback, control action will be taken. So similarly here, from the reward given by environment, this agent will take some action for that environment, and that is the reinforcement learning. This is how we can categorize a particular learning problem in either supervised learning, unsupervised learning, or reinforcement learning. This is all about today's lecture. Thank you very much.